Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 2C assignment. Let's start with number 1A here. Let U equal 1, 2, 3, 4, 5, 6, 7, 8, 9. Find the complement of A equals. Okay, so remember U stands for the universal set, so these are the only numbers that we're concerned about for this problem. And so if set A is 2, 3, 6, 7, and 8, the complement of A prime, would be everything that's not in there. So there's 2, 3, 6, 7, and 8 are all taken care of here. So the complement is going to be all the leftovers, 1, 4, 5, and 9, right? Because if you add the complement to the set, it should give you the universal set. So A, complement of A and A add up to the universal set every time. All right, let's look at 3. Let U equal whole numbers between 10 and 20 inclusive, so including 10 and 20, and then A are the factors of 120, and then B are the multiples of 3. All right, so first thing says list the elements of A. Okay, so A is, let's see, factors of 120. Now here's the thing, I really want to know what U is also, so I'm going to list U up here as well, because I know that A and B can only include the numbers that are in U. Okay, the universal set. So whole numbers between 10 and 20 inclusive. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, right? So the only things that can show up in A are any of these numbers here, okay, that work. So factors of 120. So if we look at 120, factors of 120 are 1 times 120, 2 times 60, 3 times 40, 4 times 30, right? 5 times, let's see, what's that going to be? Is that 5 times 24? Let's see, 6 times 20, 7 doesn't work, 8, I don't believe, maybe 8 will work, let's check. So 120 divided by 8 gives us 15, so that does work. Let's see, does 9 work? I don't think 9's going to work. Divided by 9. You can always put it in to check. Nope. 10 will work though. 10 times 12. And I think those are all the factors. So I know that took a little bit of time, but now all we want to do is go through and fix this number so you can actually read it. That's 120. And pick all the numbers in here that we listed that are in between 10 and 20 inclusive. So 20, 8, 15, 10, and 12. Those are all the ones that work for A. So A is going to be, I'm going to list them in order. 10, 12, not 8. I don't know why I circled 8, sorry. 10, 12, 15, and 20. Okay. So set B is going to be multiples of 3. That should be a lot easier to figure out. So multiples of 3 in here are going to be 12, 15, and 18. 12, 15, 18. Okay, so this was A, this was B. C is list A prime, okay? I'm going to do this just to make this a little cleaner. No, I'm going to leave that there. That's fine. We'll live. So C is going to be what A prime is, and that's going to be everything in the universal set that's not in A. So 10's in there, but 11 isn't. 12's there, but not 13 or 14. 15's there, but we need 16, 17, 18, and 19, and 20 is in here. So there's our A prime. Okay. D is going to be what's in B prime? So B prime is going to be everything that's in the universal set that's not in B. So that's 10, 11, 12's there. So we need 12. No, sorry, I just said we had 12. There we go. 13 is what we needed. 14, not 15, but 16, 17, 18's there. So 19 and 20. There's B prime. Okay. H is A prime union B. So A and B, the union of. So anything that shows up in either of these. So A prime union B is going to be, I'm just going to list, let's see, 11. 12 fits in there from it's a combination of these two. 12, 13, 14, 15, 16, 17, 18, and 19. So basically everything except for 10 and 20, right? Yep. Okay. I is A intersect B prime. A intersect B prime. It's going to be everything that's in A and in B prime. It has to be in both. So 10, 12, 15, 20. We got 10, no 12, no 15, but we got 20. So it's just 10 and 20 for A intersect B prime. And then last one on this one here is J, which is A union B prime. So everything that's in A and everything that's in B prime. So B prime's got everything except for 12, 15, and 18. But 12 and 15 show up over here. So it's going to basically, this is going to have everything except for 18 is the only one that's not listed in either of those. So 10, 11, 12, 13, 14, 15, 16, 17, 19, and 20, right? Okay. Takes a little bit of time, but it's doable. All right, suppose U and universal set, and then we got A and B. Find the number of items in U. 1, 2, 3, 4, 5, 6, 7. That is 7. Number of elements in A. 1, 2, 3. Number of elements that are in A prime. So in this one, it would be all of these, subtract these 3, right? So really it's we can't use 3, 5, or 7. So the leftover is 1, 2, 3, 4. So that's 4. But actually what you can do with this is say number that's in A prime is going to be the same thing as the number in U, the universal set, minus the number in A, right? Because the universal set was 7, number in A was 3, so that equals 4. Look, those two are the same. Okay? We know that the number in Q plus the number in Q prime has to equal the number in the universal set. Okay? So we know that the number in the universal set is 15. The number in Q prime, which is not Q, is 4. So the number in Q will be what's left over, right? So subtract 4. We get that the number in Q has to be 11. Okay? All right. Okay, that's all we have for the problems from 2C. If you have any further questions on any of these, please feel free to ask. Thanks.